Hello and good morning. Let's start with another problem in continuous with the DSU series. So the problem name is wormhole shot. So problem is like Farm John's cow have grown tired of daily requests that they shot themselves before leaving the barn each morning. They have just completed their PhD in quantum physics and are ready to speed things up a bit. This morning, as usual, Farmer John n cows number 1 to 10 to power 5. Conventi number 1 to n are scattered through the barn at n distant locations. Also number 1 to n. So that cow I is located at Pi. Okay, so they are cow from 1 to n and each cow is located at some position Pi and Pi belong to 1 to n. Okay. But this morning there are also m wormholes. Okay, this range numbered from 1 to m, where wormhole I bidirectionally connect location AI and BI and has breadth WI. Okay, so there are wormhole I bidirectionally connecting location AI and BI. So at AI and BI there will be some cow. Okay, with some number. At any point, two cows located at opposite end of wormhole may be simultaneously swapped places through the wormhole. Okay, so along this bidirectional wormhole or say edge, these two cows located at AI and BI can swap. Okay. The cow must perform such swap until cow I is at location I for all 1 to n. Okay, so all these PI given n different PI and all these PI are distant and they belong to 1 to n and cow I is located at Pi. So we need to move these cow across edges in such a way that cow I reach to position Pi says that Pi equal to I. Okay, so that's belong that one cow should be at 1, two cows should be at 2 and simultaneously. Now, the cows are not eager to get squeezed by the wormhole. Help them to maximize the breadth or least breadth wormhole which they must use to short them. It is guaranteed that it is possible for the cows to short themselves. Okay, so these cows are moving in the wormholes, and we, while moving across for all the cow pairs, we need to maximize this breadth of wormhole. Okay. Suppose the cow move. Okay. Now let's move to input test case. So first we are given two integer n and m. Okay. Nm. Second line contain n integer p1, p2, p2, pn. It is guaranteed that p is a permutation of 1 to n. So all the cows are at different location. And all 1 to n number must be covered as they are n numbers. And p1, p2, pn are representing positions of cow. Next, for each line I from 1 to m, line I plus 2 contain integer ai, bi, and wi, where ai, bi indicate that there is a wormhole with breadth wi from ai to bi. Okay. Output format single integer the maximum minimum wormhole breadth which a cow must squeeze itself into during the shorting process. If a cow do not need any wormhole to short themselves, output minus 1. Okay. Let's move to the sample input and let's see what it's saying. Okay. So we are given NS4 and MS4. So there are 4 cows and 4 wormholes. Okay. These are locations of cows and these are wormholes, that is edges. So now let's create this graph. There is a edge from 1 to 2, 1 to 3, 2 to 3 and 2 to 4. And their breadth or weight is given as 9, 1 to 3 as 7 and 2 to 3 as 10 and 2 to 4 is 3. Now let's see what we need to do. Okay, so we want to short the no just okay. So now first before this let's that 1 is at location 3. So 1 is at this position and 2 is at 2 position and 3 at 1 and 4 is at 4. So this representing cow number 1 is at location 3. Cow number 3 is at location 1. Let's move. So we want to sort those cow numbers such that they such that they are at location cow I at location I. So we want this 1 to be at location 1, 3 to be at location 3. Or how we can do that? We can swap swap uh, cow number across edges. Okay. Okay. And for answer, what we want is that while we are swapping, we will move nodes across edge, suppose E1 and E2 and dot dot dot. And if we take minimum of these values, we will get some E, and we need to maximize this E. Okay. So this is the problem we need to solve it. Okay. For sample input, let's see how we can move this 1 to 3 and this 3 to its position. So one of the solution is that move cow with number 1 with node cow with number 3. So what happens is that this 3 will come here and this will go here, and this process is going to use h having value 7. So minimum of 7 is going to be 7. So for this answer is 7, and we need to maximize this answer. Another possible solution is that 3 1. Okay. So another possible solution is that we move cow with number 1 with cow with number 2, that move this 2 here and 1 here. Okay. Using no edge with weight as 10. So this is going to use edge with weight 10. Next, move this 2 cow with value 1 with 3. So what happened going to this here will come 3 and here will come 1. Using weight, this edge as with weight 9. So this is going to add 9. Next, what we are going to do, swap this part 2 and 3. So and then this 2 going to swap with 3 with adding weight as 10. So this part, now 3 will come here and 3 will come here and 2 will. So now each node is at I, 1 belong to 1, 2 at 2 and 3 is 3. So now answer is going to be minimum of 10, 9 and 10. That is going to be 9. So now the answer is 9 and we need to maximize this answer, that is 9, and in first case we get 7. So for our problem we need to find this maximum answer. So by using this swapping we can get the max answer. So for this problem there may be another procedure to solve this, but for this problem the maximum answer we can achieve is 9. Okay. Now next move to some observation. And for this problem we need DSU. DSU having method find and merge. For this problem we need only these two methods. Now we need some observation. So first observation is that if we can solve this we can solve this problem, suppose with the suppose solve this problem with answer as k, then for value z lesser than k we can definitely solve it. Let's see how. Okay, let's see how. Three. Suppose for this answer 9 we can suppose answer is 9, so we can travel across all the edges having weight greater than equal to 9. So if we remove this edge and this edge, we can move this 1 to here and then 3 to here, then 3 to here. So using all the edges having weight greater than equal to 9, we can sort this, and for if we take the minimum of these, then answer is going to be 9. Okay, now let's suppose we want answer to be 7, then we will remove all the edges having weight lesser than 7, then this is going to be removed. Again, if we try to swap node, then we can definitely swap directly here or using this, and in this case we can use all this as, and its minimum going to be 7. So if we are able to solve this problem for value 9, then we can solve this problem for 7 also. So if we are able to solve problem for higher weight edges, and if we add any edge having value lesser than that, then definitely if while traveling on the edges of higher value we can able short it, and adding that extra is definitely not going to affect the answer. So definitely we can solve problem with lesser weight, because this is going to cover all the edges having higher weight, and we are able to definitely solve for that. Okay, now next check, if we want to get answer as 10, then we need to remove all the edges having value lesser than 10. That is this part going to be removed, and this is going to be removed, and this is going to be removed. So now this 1 cannot be moved to this position, and this 3 cannot be moved to this position. So for a value greater than 9, that is 10, we are not sure whether we are able to solve it or not, because for 9 some edges having value lesser than 10 are removed, and if with 9 we are able to solve it, but some edges are removed. Okay, I hope this makes you clear. So so for any z lesser than k, z1, z2, dot dot dot, we are if we are able to solve for this, then we definitely able to solve for all the value lesser than 3, and for all the value greater than k like p1, p2, we can't say whether we were able to solve it or not. So this answer is somewhat monotonic. So first solution is that we can use binary search on this answer, and for a mid we will add all the edges values having weight greater than equal to mid, and then we will check whether whether mm, cow with position I and its cow with value I and its position of I belong to same component or not. So if their node I and its position is belonging to same component, then there definitely be going to be one path which move this I node across some edges to position of I, because both these two nodes are lying in same component. Okay, 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 okay. So this is the first solution we can use. Now next move to a second solution. So in second solution, what we want to do is that while we are traveling on nodes on values of cow, we keep on adding values and position of values, while we keep on adding edges edges in decreasing order, while value I and pose I belong to same component. So why we are doing this? So we are adding edges into the component in DSU, while II and pose belonging to same component. So if we are, so if we keep on adding edges having value greater than this, suppose if we achieve at a point, suppose k, where I and pose of I start belonging to same component, so the all the edges having value greater than k definitely not going to affect our answer. So this is the second solution, we can solve the problem. Mm. Now next move to the code. Okay. So first is we take NNN as input. Secondly, we take the positions in A of n. Then we take graph as input, U, V, and W. Next, we add a comparator to sort the edges on the basis of weight. Next, we create DSU. Why we have sorted these edges on basis of weight? Because in later part we are going to add these edges in decreasing order, while node I and its position not going to belong to same component. Next, we create an answer with maximum weight, and while we are adding edges, we just update this answer. Now we start moving across values, and while I and its position not belonging to same component, we keep on adding edges with higher values. Okay. At last, we check whether answer there is no need to offshot, then we need to print -1, else we print the answer. I hope this makes you clear. If you have any doubt, please make a comment. Thank you.